In this experiment, we will try to find the value of Planck's constant through a simple circuit of LIDs.
For this experiment, we'll need a DC regulated power supply together with a voltmeter, an amperemeter, a 220 ohm resistor, and some LEDs, preferably of color red, green, and blue. We won't have blue, but we'll do the other three colors. We've assembled it, putting it on a breadboard and connecting it with the different instruments with Arduino cables. And it can be the assembly process and how it is connected, it can be seen in the graph above.
Now, at high speed, it can be seen how we work it out with the circuit. We started giving the circuit more and more current with a DC regulated power supply. Our intention was to record the exact value of intensity when the LED turns on. In order to do that, we were constantly checking the amperemeter and the voltmeter and recording each value, what later we will use to compute the constant. All the data of all the different LEDs can be seen in our lab register.
We carry out the same procedure with the different LEDs and write down the results of each one. Once we obtained all the results, we have decided to do the calculations following the data obtained from the red LED. Knowing that the energy is equal to Planck's constant multiplied by the frequency and equal to the charge of an electron times the voltage, we were able to obtain the following equation to obtain the approximate value of Planck's constant, taking into account that the frequency is the speed of light divided by the wavelength, which in this case is the wavelength of red. The only unknown is Planck's constant. Once calculated, we were able to compare our result with the Planck constant. Hence, we calculated that there was only a relative error of 2.52% between our constant and the real one.